Okay, so what we've been talking about so far, clipping that mic right there. So what we've been talking about so far is polynomials, and mostly how to factor polynomials. So what we've talked about is, first of all, GCF factoring. So something like 5x cubed plus 15x. So in GCF factoring, what we're saying is that we've got multiple terms in our polynomial, and those terms might have something in common that they can both be divided by. Of course, a factor being the thing that they can divide by. So if we look at the two terms here, we've got 5x to the third and 15x. So first of all, their coefficients, 5 and 15, can both be divided by 5. So we'll be taking a 5 out. And then the variables themselves, x to the third and x, can both be divided by, well, the smallest power of x, which is x to the first in this case. So we'll be taking an x to the first out. And this is frozen. Let me restart this. Okay, there we go. Okay, so we can take a 5 out and we can take an x out. So when we do that, we divide this common factor out of both of these terms. 5 divided by 5, well, that's 1, so it cancels. Then x to the third divided by x leaves us with x to the second, or x squared. Then 15 divided by 5 gives us 3. And then x divided by x, again, cancels. So there's our two factors. So the factored form here is 5x times x squared plus 3. Again, when we write a factored form of a polynomial, this factored form had better be able to multiply back to the original. So 5x times x to the second is 5x to the third, and 5x times 3 is 15x. So yes, this does work. The other type of factoring that we've talked about is sort of a special case. So if we have something like 16x to the second minus 9, this is a polynomial in a special form called a difference of squares. Difference because between these two terms we're subtracting. And of course squares because all of these numbers are perfect square numbers. So 16 is a perfect square of 4, x squared is a perfect square of x, 9 is a perfect square of 3. So when we work with a difference of squares, we can factor them all the same way into two factors. We take the square root of all these numbers and fill them in, so 4x and 3. Same thing here, 4x and 3. And then this one gets a minus, this one gets a plus. Because again, when we factor a difference of squares, like we said last time, we get conjugate binomials. Conjugate meaning that they're the same numbers, but they have a different sign. So once more, these are the two types of factoring that we've gone over. We've gone over GCF factoring and difference of squares factoring. So do we have any questions before we move on? Nope, all makes sense. Okay. So now, what if we have a polynomial like this? X squared plus 4x plus 4. Okay, so this one doesn't have 2 terms in it, it has 3 terms, making it a trinomial. But perhaps more importantly, this isn't just a trinomial, this is a quadratic, like we talked about last time. So that means that it is in the form ax squared plus bx plus c. So that means that our a in this case is 1, because remember there's a 1 in front of that x there. B is 4, and C is also 4. So if we try our previous 2 types of factoring on this, first of all GCF, well, these 2 have x's in common, but this one doesn't have an x, so we can't do that. These 2 have 4's in common, but this one doesn't have a 4, so we can't do that either. That means that there's no greatest common factor for all 3 of these, besides 1, of course. Okay, so what about difference of squares? Well, even more problems there. A difference of squares has to be a binomial. This is a trinomial. It's got too many terms. Besides that, we're not even doing a difference. So neither one of those works. So what are we going to do? Well, we need a new method of factoring. First of all, this thing being a trinomial is not in a form that we can factor right now. We're going to need to change it a little bit so that we have more information, at least enough information for us to be able to factor. So to do that, we have a method called AC method. And that refers to the A and the C in our quadratic form. So first of all, let's figure out what A and C are. So what is my A? Compare it to the form. Not x. Remember, A is the thing in front of x. 1, yeah. And then what's my C? 4. So my A is 1, my C is 4. What the AC method tells us to do is to multiply those 2 numbers. So 1 times 4 is 4. Now what we're going to do with that number is we're going to find factors for it, numbers that multiply to get 4. So 1 times 4 works. 2 times 2 works. We've also got to remember that -1 times -4 also works, and -2 times -2 also will get us a positive 4 if we multiply it. Now what we're looking to do with these factors is find a pair of them that will combine or add to get this middle number, because we want to replace this middle number with a pair of these factors. So which pair of factors will combine, or again add, to get positive 4? 2 and 2, yeah. If we add 2 and 2, we get positive 4, and if we multiply 2 and 2, we get positive 4 there. So what we can do now is we can use these factors to replace this term. giving us x squared, then use this one right here, plus 2x, use this one right here, plus another 2x, and then drop that plus 4 down. So once again, all we've done is we've split this middle term into 2. Now we have enough information to be able to factor this thing. And there's 2 ways that we can go about doing that. I'll show you both of them. One way is a method called factor by grouping. What it says is we can actually break this new thing into 2 parts and then use GCF factoring on both of them. So let's focus on the first one. We have x squared plus 2x. And let's do GCF factoring on that. So what do both of these things have that they can be divided by? What's their common factor? What? Not 2. They both have what? X. So they can both be divided by x. And if we divide that out, x squared divided by x is x. 2x divided by x is 2. So we have x plus 2 left over. We'll do the same thing to the other side. So 2x and 4 can both be divided by what? 2. Good. And if we divide that out, 2x divided by 2 just leaves that x. 4 divided by 2 is 2. And here's the important part. See these 2 things in parentheses? Do they match? Yes. If these things left over in the parentheses match, then we have factored this thing correctly, and we can go ahead and write our answer. So the first factor is whatever we have that's left over that matches. So the thing that matches here is x plus 2. That's one of our factors. The other factor is the thing that we took out from both of them. So this one we took out an x. This one we took out a positive 2. There's our second factor. Just so happens that this is x plus 2 times x plus 2. And that's factor by grouping. So one reason you might want to use this is, again, because of this matching thing. As long as this matches, you know that you have factored correctly. If it doesn't match, then you know you need to go back and see what else you can take. One of the drawbacks to this method, though, is that sometimes that factoring can get confusing because you have to make these match. If they don't match, then you haven't factored correctly. So you might have to play around with what you take out, like what number you take out, what sign you take out. You might have to take out not just a 2, but a negative 2. So it can get a little bit complicated. But again, it's nice because you know if you did it correctly. Let's see the other method that we can use. So let's quickly back up to this part where we got 4 terms. We split this middle one into 2. Instead of using factor by grouping, the other method that we can use is called the box method, and it's actually the method that I prefer. The box method makes a framework for you to use to factor this. Draw up a box, split it into 4 parts. Each of these little cubby holes will contain one of these 4 terms in our polynomial. So here's how it goes. The first term, in this case x squared, goes in the first box. The last term, in this case 4, goes in the last box. Then the 2 in the middle, it doesn't really matter which of the other 2 boxes we put them into. I usually take this one and put it here though. So 2x is going to go here. What does matter is that its sign comes along with it. And that sign is going to sit out here on the top. So this 2x has a positive. That positive is going to sit right here on top. This 2x, well, there's only one more box for it to go into. And again, its sign has to come with it. And its sign is going to sit out to the side here. Okay? So now that we got everything fit into this framework, we can go ahead and work on factoring it. Now here's one of the nice things about this. We don't actually have to factor it. We just have to find the greatest common factor. So like this row right here, we want to find the greatest common factor between these two numbers. So what do x squared and 2x have in common? They both have x. So since this row has the greatest common factor of x, we'll stick an x out here. All right, how about this row? We've got 2x and 4. What can they both be divided by? What do they have in common? 2. So we'll stick a 2 out here. Same thing for the columns. So this column here, we've got x squared and 2x. What's their greatest common factor? Again, what do they have in common? X. And here, this column, what do they have in common? Yeah, they can both be divided by 2. And hey, there's our 2 factors. X plus 2 across the top here, and our other factor is x plus 2 down the side here. So whether you use factor by grouping or the box method, you'll get the same answer as long as you perform them correctly. Box method, I think, is a little bit easier to understand. At least it's easier for me. But the problem is you don't have that nice little safety net with the matching thing. If you don't get the actual greatest common factor for the rows and columns, you're going to have the wrong answer. So there's no way to check. Of course, unless you multiply them back together. Any questions? All right, let's practice this. Let's try another one. Y squared plus 3y minus 40. So just like the last one, it's always a good idea to start and check and see if we can do GCF. Well, we got y squared, 3y, and 40, and I don't see a common factor between all 3 of these. These share y, that's nice, but this one doesn't have a y. And 40 doesn't share a common factor with any of the other terms, so yeah, we can't use a GCF here. And of course, this isn't a difference of squares either. So, like the last one again, we need to use our AC method. So what is the A here? What is the leading coefficient? 1, good. And what is the C?
40,
Negative 40, good. Yeah, we have to include that sign. All right, so A is 1, C is negative 40. A times C gives us negative 40. So we want to find factors of this number. And again, we want those factors to combine to get, in this case, positive 3. So we can do 1 and 40. I won't worry about the signs just yet. What else multiplies to get 40? 2 and 20. What else? 4 and 10. Getting closer. There's one more. Do what? Okay, think about this. 40 ends in a 0, so it's divisible by 10, and what else?
Oh,
5. So 5 has to be a factor.
5 and 8.
Excuse me, yeah, 5 and 8. All right, now remember, these need to multiply to get negative 40. So one of these things, one of these pairs, is going to get us 3 if we combine it, but multiply to get negative 40. So when we find that pair, one is positive and one is negative. So which pair can work that way? The difference of 4 and 10 is 6.
Oh,
So that's,
5 and 8.
yeah, 5 and 8. There we go. So if we make 8 positive and 5 negative, those multiply to get negative 40. But if we add them, negative 5 plus 8 gives us the positive 3 we're looking for. So there we go. All right, so now we'll go ahead and put that in. Replace 3y with negative 5y and positive 8y.
Doesn't matter which,
Excuse me?
I would say it doesn't matter which one's made negative.
Yes,
Yeah.
because remember we need it to be positive 3, not negative 3. Good question though. All right. So I'm just going to do box method for this one. So I've got my 4 terms. I'll draw up my box with the 4 spaces in it. I can't draw a straight line to save my life apparently. So again, first term goes in the first box. Last term goes in the last box. And then these two in the middle, it does not actually matter which one goes in which box. Again, I usually like to put this one into here. So I'm going to put 5y in this box. But remember, its sign comes along with it and sits outside. Same thing with 8y. It's going to go in this box. Its sign comes along with it and sits on the outside. Now that we've gotten everything filled in, we can go ahead and factor. So, this row right here, what is their common factor? Y. They can both be divided by y. How about this row? 8? Yep. They can both be divided by 8. This column. Y. This column. 5. Perfect. So our two factors, again, one of them is across the top. y minus 5. And then the other one is down the side, y plus 8. Now here's a question for y'all. Does it matter the order that I write these in for my answer? No? Absolutely right. It does not matter because we're multiplying. This is y minus 5 times y plus 8. And if you remember, the commutative property of multiplication says it does not matter which one comes first. So I could write this as y plus 8 times y minus 5. Any questions? Still making sense? All right, one more thing I want to point out about this one and the last one we did. Let's look at those factors we found for our AC. So we did our AC, we got 4 here, and we got positive 2 and positive 2. That's what we used to replace the middle term. Look at our answer. We have x plus 2 and x plus 2. The one we just did. The two factors that we found for our AC that we used to replace this middle term was negative 5 and positive 8. In our answer, we have negative 5 and positive 8. Now, the other thing that is similar about these two problems we just did is, what is our leading coefficient for both of them? What is our A term? Well, what is it? 1. Same thing here. Our leading coefficient here, even though it's not said, is 1. So, here's the takeaway. If your leading coefficient is 1 with these trinomial things, with these quadratics, then when you factor it, once you get these two numbers from your AC, you can use them to make your answer. So like this one, we found negative 5 and positive 8. Well, I know the variable we're using is y. So I would just say it's y, then filter this one in, negative 5. And then again, the variable we're using is y, positive 8. So you can skip over all that box method or factor by grouping stuff if you realize that you have a leading coefficient of positive 1. Any questions? Okay. Well, obviously that means that sometimes we won't have a leading coefficient of positive 1 and we won't be able to use that shortcut. So let's do one where that is not the case. 15y squared plus 7y minus 2. All right. So, again, leading coefficient, or our A term here, is not positive 1. It's 15. So we cannot use our shortcut method.
Wait, what?
Excuse me?
You said we can't use the shortcut method?
Yeah. So remember, with this previous one, we had a leading coefficient of 1, positive 1. So the shortcut there is, okay, we get to AC, now we just put these two numbers into our answer. This one, we can't do that because our leading coefficient is not positive 1. We've got to go all the way through all that factoring stuff. So we've got to do AC and we've got to do box method. So first of all, what's my AC? What is my A and my C? So multiply those two. Negative 30. Good. right, now we've got to find factor pairs. So starting with 1 and 30. Well, we also know that 2 and 15 work. So we just did that. What else? 3 and 10. 5 and 6. And I believe that's all of them. So which pair can combine in some way? Remember, one of them's got to be negative, one's got to be positive, since we got a negative 30 here. Which one can combine to make 7, that middle term? What was that? Can make 7? How? 3 and 10, yeah. So, again, one of these has to be negative, one of them has to be positive in order for them to multiply to get negative 30. Okay? And when we combine them, when we add them, they need to give us positive 7. So if we make this positive 10 and negative 3, negative 3 times positive 10 gives us negative 30. Good. Negative 3 plus 10 gives us positive 7. Also good. So we can go ahead and use these to replace that middle term. Now we've got 15y squared minus 3y plus 10y minus 2 just drops down. So now we've got our 4 terms, we can use our box method. All right, what goes in the first box? 15y squared. What goes in the last box? Anybody? Negative 2. All right. It doesn't matter which one we put in here, but which do we want to put? All right. Did you say 10y? All right, sure, okay. If we put 10y in there, what's going to be on top? On top here. Yeah, sign right here. Positive. Because 10, what we just put in there, was positive. All right? So what goes in this box? 3y. And on the outside here? Negative, because the 3y was negative. All right. So now we need to factor our rows and columns. So this first row here, 15y squared and 10y, what is their common factor? There's actually 2 things we need to take out. Y is one of them. They have y in common. Think about 15 and 10, those coefficients. What can they both be divided by? What? 5? Yeah. So we can take a 5 and a y out on that row. How about this row on the bottom? Actually, let's come back to this one. Let's not do that one quite yet. Let's do this column. So 15y squared and 3y, what is their common factor?
Y and 3.
Good. All right, and in this column? Just the 2. Okay, so let's come back to this row here. We have 3y and negative 2. Or we can really just forget about that negative. We don't need to worry about it. 3y and 2. What is their common factor? Their greatest common factor. What was that? 1. Good. Excellent, yes. 3 and 2 do not share really a common factor. They're both prime. But that doesn't mean that we can't take something out. Remember, what we're asking here is what's the biggest thing we can divide both of them by? Well, we can still divide both of them by 1. And if that's the biggest thing, then that's what we take out. Very good. So, there's our two factors. 3y plus 2 and 5y minus 1. Excellent. What questions do we have? None? Making sense? All right. I got one more for us then. It's going to look kind of complicated at first, but I promise it works the exact same way as every other thing we've been doing today. So let's have 3x squared minus 14xy minus 5y squared. So this looks kind of different because it's got not just x's, not just y's, but both x's and y's. In fact, it kind of looks like we took two of these quadratic things and stuck them together, put them end to end. But just because we have more than one variable here doesn't mean that this actually isn't the same thing we've been working with. We've still got ax squared plus bx plus c, and we can still do our AC method. So what's our a? 3? And what's our c? Be careful. 5, negative 5. So our a is 3, our c is negative 5. 3 times negative 5, 15, negative 15. All right, let's find those factor pairs. So 1 and 15, 3 and 5, and that's it. So remember, we want a pair of these that will multiply to negative 15, but combine to negative 14. 1 and 15, which one is positive? Remember, we want negative 14 when they combine. So positive 1, negative 15. All right. So we're going to rewrite this thing now. 3x squared plus 1xy. I can just write that as xy. Because remember, we can just pretend the 1 is there. Minus 15xy, and then drop that negative 5y squared down. All right. So we've got our 4 terms. Box method. All right. So what goes in that first box? Yep. 3x squared. What goes in the last box? Good. Negative 5y squared. What do we want to put here? Negative 15xy? Okay. Now if we put that here, what goes up on top here? Negative. Good, because that 15 is negative. Alright, well, only one place to put the xy. But what comes out to the side here then? Positive. Good. Alright. So now that we've gotten everything into the box, we can start to find our GCFs. So let's look at this first row here. What can we take out? 3. Anything else? And x. Good. All right. How about this row on the bottom?
On the bottom?
Yeah, on the bottom. The row. Yeah, just a y. I mean, technically we are taking one y out, but we don't need the 1. Okay. So how about this column here? Yeah, just x. And what about this column here? 5y. Good. There's our factors. X minus 5y times 3x plus y. Perfect. Any questions? Think we got it? Seem pretty comfortable with it? All right. So, Friday, we'll be having a quiz, which means we're not going to be meeting in class Friday. I'm just going to send that quiz out through email, and you can take it. It'll be due, like Monday. That quiz is going to go over all the stuff that we've done with polynomials, so know your degree and leading coefficient, know how to do GCF, know how to do difference of squares, and know how to do this AC and box method thing, or factor by grouping if that's what you like better. All right? So I will probably see you Monday then, but remember, quiz Friday. Have a good one. Thank you.